Okay, in this lesson we're going to talk about two new rules, product rule and quotient rule. First thing, product, that means multiply. So if you have two functions that you are multiplying and you want to take the derivative, you could, like in case of number one, actually distribute everything and then deal with the power rule. Then you would actually be stuck on two, like how to deal with that. You don't know how to do that one yet. So we have this rule, and what you're going to do is you're going to take the derivative of the first group, times it by just the plain old second group, and then add that to just the first group times the derivative of the second. So I want to point a couple things out. First of all, it's okay if you got these two mixed up, because when you're multiplying, it doesn't matter the order that you're multiplying. Okay? Second thing is, you could actually switch these two things around and it would be okay, because with plus, by the way, it doesn't matter the order. Now if this was a minus, we're going to get to that with quotient, that would be an issue. Okay, also I want you to notice that I'm only doing one derivative per group. Okay, no two derivatives back to back. So let's just go through the first example, h prime. We're going to first start by taking the derivative of the first group using power rule, 2x plus 3. Then just write the second group, okay? Plus, now I get to just write the first group and take the derivative of the second group, which would just be 2. The best thing is we're just going to leave our answers just like this. On the AP test, you can leave your answers unsimplified, totally fine. Same thing on my test. If this was multiple choice, you would need to simplify, okay? But that's not for this lesson today, so we're just going to leave our answer like that. All right, I wrote really big, so we're going to work number 2 down here. First thing, if there's no parentheses, I think it's easiest if you go ahead and put in parentheses. All right, second thing is derivative of the first. That's 12x squared. You should be getting really good at that by now. Then we just write the second, plus. Then you just write the first, and the derivative of the second, so if I can squeeze it in, is cosine x, and that's it. That's all you got to do, okay? Looking at number 3, a little bit different, okay? I'm going to scratch out that 2, and I'm going to go ahead and write 4x squared plus 5 just twice, because they're the same thing. And again, you could multiply this out and just use power rule, but because we're just learning product rule, let's practice it. Derivative of the first, which would be 8x times 4x squared plus 5, plus, now just write the first term, times the derivative of the second term. And again, if you think you're getting things switched up, it's actually totally okay with the product rule, as long as you don't do two derivatives back to back. So notice the 8x's are not back to back. Okay, quotient rule is actually very similar. Okay, so remember how with product rule we did f of x times g of x plus just f of x times g prime of x? So here's what we're going to change for quotient rule. First of all, this plus, I'm going to take that out. You may have guessed it, I'm going to put in a minus. Second, I'm going to put this all over the denominator squared. Now your book has a great proof of why this works the way it does. Notice again, derivatives only once. Okay? So I'm not going to go into why, I'm just giving you the formula, and then we're just going to apply it. Okay, so y prime. Alright, so here f of x is the top, and the bottom is the g. So I'm going to go ahead and write my big fraction bar. Derivative of the top would be 7. I'm going to put it in parentheses even though I may not need to. It just helps me stay organized. Then just write the denominator minus, now I just write the numerator and the derivative of the denominator. Again, notice the derivatives, 7 and 2x, did not go back to back. There's a minus in the middle. And then the last thing, don't forget, all over the denominator squared. And again, we could simplify, but we do not have to, so we're going to box and move on. Alright, looking at number 5, it looks like it's kind of like a quotient within a quotient, but if you just do something real simple, change this to 3 minus x to the negative 1, then you get something that looks, it's just a simple algebra step, makes it look like the other problems. So, by the way, if you think you're going to forget that all over denominator squared, go ahead and write that first. Okay, derivative of the top, derivative of 3 is 0, negative 1 times negative x, that's positive 1, x, and then if we we subtract 1 from that power, we get negative 2. Then just write the denominator, minus. Now we switch it up. Just write the numerator times the derivative of the denominator. I should put it equal there. And that is your answer. Okay, tangent doesn't look like a quotient, but it actually is. I'm going to rewrite this as sine x divided by cosine x. So my y prime is going to be, write the fraction. This was a trig identity, by the way, you learned last year. Derivative of sine, that's cosine x. Then we just write the denominator, which is also cosine x, minus. Now I just write the numerator times the derivative of the denominator, all over the denominator squared. Okay, this would be okay, except I want to simplify this down, and I'll explain to you why in a minute. Okay, first term, when I square, or cosine x times cosine x, that's the same as cosine squared x. Okay, ooh, I made a mistake. Did you see it? If you're watching this video, derivative of cosine is not sine, it's negative sine, right? Negative. I missed that. Oops. But now I have it, so everything's good. Alright, negative times negative is positive, and we have sine squared again, times itself is squared. And then the denominator is cosine squared x. Now this is an identity some people forget, but this thing right here, Pythagorean identity, equals 1. So we end up getting 1 over cosine squared x. And again, using a different identity, the reciprocal identity, we get secant squared. Now if you were like, I don't remember those identities, that's okay, because this is something I'm going to ask you to memorize anyway. Okay, so derivative of tangent is secant squared. This is now your third one. If you turn the page, we have all 6 right here. So derivative of sine is cosine x, derivative of cosine is negative sine x. You already knew these, hopefully you did. Okay, the new ones, derivative of tangent, that's secant squared x. And I'm going to go ahead and say cotangent, because there's a co here. The only difference is it's going to be negative, and this secant squared is going to be cosecant squared x. Okay, so if you just learn this one, you can learn the next one, just the pattern. A co means negative, and then another co. We could derive the next one, but I'm going to go ahead and give it to you. It is secant x tan x. Okay, so derivative of secant x is secant x tan x. So the derivative of cosecant x, you're going from here, is negative. Instead of secant, cosecant. Instead of tangent, cotangent. So you do have 4 more, but really you just have 2 and then a pattern. I suggest you use flashcards. Okay, number 7. If you don't have parentheses, put them in. This is a product rule, and so we are going to first just take the derivative of the first item times the second item plus just write the first item. And so this is why this is here, because we didn't know the derivative of secant before, but now we do know that it's secant x tan x. And that's it. That's your answer. Alright, number 8. Now we have 3 products. We could do a product rule within a product rule. We could just do a little bit of algebra and multiply that out. So x squared times x squared is x to the 4th. If you kept multiplying this out, you get x squared minus x cubed minus x. I'm not spending time on that because that's something you've been doing since Algebra 1. Alright, now we can just use regular old product rule here. So you're going to have 4x cubed plus 2x minus 3x squared minus 1 times just the second group. And then you're going to add just the first group. It's the same thing we were doing on the front, times the derivative of the second group. And it's a lot of writing, but you don't have to simplify it, so it's really not too bad. Alright, the next 2 I'm not going to work in this video, but I am going to kind of show how the overall setup would be. Alright, so multiply here. We do have a quotient, but let's just pretend that's not a quotient. Your h prime would be something times something plus something times something, right? Okay, and that would go there, and that would go there, and then these outside pieces would go the 2 derivatives. Okay, the hardest thing about this would be the derivative of this quotient is going to go right there at f prime. So you're going to have to do a quotient rule inside the product. Okay, likewise for number 10, I'll just do this one down here. You do have a quotient, so your derivative would be, it would be parenthesis, parenthesis, minus parenthesis, parenthesis, and all of this would be okay. The hardest part about this would be you have a product. So this derivative would go right here. So you would have to do a product rule right there.